Try to picture absolute nothingness. We usually imagine a dark, empty room, but even darkness and emptiness require space. Before our universe existed, there was zero matter, zero space, and zero time. Our brains rely on physical dimensions to make sense of reality, so a state completely devoid of physical laws defies human intuition. There was no where for anything to be, and no when for it to happen. Yet this absolute zero state held a paradox. Somehow, hidden within an environment that lacked literally everything was the potential for infinite energy. The universe we know did not slowly assemble from pre-existing materials. It originated from this unmeasurable, dimensionless state, bursting into reality all at once. Exactly 13.8 billion years ago, that hidden potential broke open. We call this the Big Bang. The name can be misleading. This was not a localized explosion expanding inside an empty room. Space itself is what was expanding, carrying all of that new energy outward with it. In its first fractions of a second, this newly formed space was hostile. It was unimaginably dense, packed entirely with chaotic, blindingly hot energy, and completely devoid of structure. If the universe stayed this compact, it would remain a sea of formless heat. Its ability to create anything complex depended entirely on one mechanical process. It had to push outward, stretch space, and cool down. A thermodynamic countdown had started. As the spatial void rapidly expanded in every direction, the extreme concentration of heat finally had room to dissipate. With the heat dropping, pure chaotic energy slowed down, condensing into the first building blocks of matter, subatomic particles like quarks and electrons. These reactive particles immediately sought stability, pulling together to form heavier, distinct central cores. Simply by expanding and lowering its internal temperature, the universe triggered the exact conditions required to manufacture its own physical foundations out of thin air. The universe continued to expand for another 380,000 years. Eventually, the temperature dropped to a specific threshold, cool enough that these subatomic particles could permanently bond, creating the very first atoms of hydrogen and helium. Up until this point, free-floating electrons had acted like a thick fog, trapping light and bouncing it around internally. But as those electrons were absorbed into stable atoms, the fog cleared. Light could finally travel in a straight line. We can still see the physical evidence of this clearing today. This image is a heat map of the cosmic microwave background. It captures the residual radiation from that exact era, showing the distinct temperature variations echoing across space. The existence of this map proves a distinct mechanical shift. The universe successfully transitioned from an opaque, blinding soup of raw energy into a vast, structured, and transparent expanse. Now filled with massive drifting clouds of hydrogen gas, a new force took over: gravity. Over millions of years, gravity began pulling these scattered gas clouds closer and closer together. As the gas compacted, the inward pressure created immense friction and heat. Right at the center of these tightening clouds, temperatures spiked until nuclear fusion ignited, birthing the first stars. Gravity didn't stop at individual stars. It continued pulling on a massive scale, dragging billions of these stars together into vast gravitational neighborhoods, the first galaxies. While the outward expansion of the universe was pushing everything apart, the inward pull of gravity fought back, successfully organizing raw matter into the immense structures we see today. About 4.6 billion years ago, within our own Milky Way, a specific cloud of gas and ancient stardust began its own gravitational collapse. The extreme pressure at the dead center of this collapsing cloud ignited into our host star, the Sun. Not all the material was pulled into the star. The heavier, leftover debris spinning in orbit began to violently collide and fuse together over millions of years, eventually accreting into solid planets, including Earth. The creation of our solar system was a standard, predictable byproduct of the exact same physical mechanics that had been operating since the first particles formed. Early Earth was a violent, molten environment. But as its surface cooled, a solid crust hardened, allowing massive amounts of water vapor to condense and pool into vast liquid oceans. These stable liquid environments functioned as complex chemical mixing bowls. Under the right conditions, distinct chemical compounds combined to form the first microscopic biological life. Over the next few billion years, those single-celled organisms underwent a brutal process of biological evolution, branching out, adapting, and growing into massive, dominant life forms that ruled the planet. The calcium in those skeletons, the iron in their blood, and the carbon in their cells did not originate on Earth. Every biological component was forged inside the extreme heat of the early stars before being scattered across the galaxy. Eventually, the evolutionary chain produced early humans. They possessed a biological trait unlike anything else on the planet, the capacity to consciously observe, question, and record their environment. Humans are not separate observers looking at the universe from the outside. We are built from its exact same materials, bound by its exact same physical laws. We are a direct continuation of that 13.8 billion year chain reaction. Through us, the universe has developed the ability to observe itself. Today, that observation shows us a universe that continues to expand relentlessly. And with every new astronomical discovery, we uncover deeper layers of physical mechanics to investigate. Yet modern science inevitably hits a boundary. We can trace the chain reaction all the way back to the zero state, but we still face the ultimate unresolved question: what existed before the Big Bang? We don't have the answer yet, but our drive to look out into the dark and search for it is simply the latest chapter in the origin story of the universe.